Hey there, kids. We are doing lesson 8 today in module 2. And I don't have any notes for this lesson. It's pretty long, so I want to get right to it. The objective, as always, can be found at the bottom. We're going to fluently multiply multi-digit whole numbers using the standard algorithm. Look at these tiny little boxes for you. And using estimation to check for reasonableness. I often do not even do that, and it's really good to check for reasonableness of the product because you could be off by a place value position or two, and you might not catch yourself. So the first thing we're going to do today is estimate the product first, and then we're going to solve by using the standard algorithm. Use your estimate after we solve, use your estimate to check the reasonableness of the product. So it's basically a 3-step activity. So the first one is kind of started for you. Basically, you're going to look at what number is in the hundreds place, but use that tens place to tell you whether to go up or down. If you have a number in the thousands, you can use the hundreds place to help you. This is, again, rounding place helping number. So 213 would round to about 200. 328 would go to about 300. 2 times 3 is 6, and then you've got your 4 zeros. It's the 4 zeros here and the 6 here that tell you you should have about a 5-digit answer. Okay, so let's jump in and use that standard algorithm. Always, it's going to be the 3 partial products for rows 1, 2, 3, unless you have a 0, which we learned about in lesson 7. Then you may just want to have 2 rows of partial products. Some students will want to have that row of zeros, and I'm not going to stop you. There's nothing wrong with it, but I will not use the whole row of zeros. It just takes up a lot of space and time. Let's jump in. 8 times 3, 24. This is always kind of a check your facts day. 8 times 1 is 8 plus 2 is 10. 8 times 2 is 16 plus 1 is 17. 17044, the first partial product, which is basically 8 times 213. Now remember the second row, we're done with this first. Hold this spot with the 0, okay, because now I'm multiplying 20 times 213. I put the 0 here, now I can just deal with the 2. 2 times 3 is 6, 2 times 1 is 2, 2 times 2 is 4. I'm not concerned with these up here because those were the carried over numbers from my ones place. Next partial product is going to be 3 in the hundreds place, so 300 times 213. We're always multiplying by that top factor. And now that I have my 0, 0 to get me to the hundreds place, then I have 3 times 3 is 9. 3 times 1 is 3. 3 times 2 is 6. And now we can add. 4 comes down, 6 comes down. 9 and 7 are 16, 17, 18, carry the 1, 4, 5, 6, 7, 8, 9. And 69,864 is our answer, which we will then reflect upon and see how close it is to our estimated answer. It's basically 6 in the 10,000s place, so we're good. We're good. We've got a 5-digit answer. We're ready to move on. Now 662, because of the 6, you could round this up to 7. Everybody's estimated answers may be a little bit different, and you could round this up as well because 37 could round to 40, 66 could round to 70. The idea here is to just get close. 7 times 4 is 28, and then count how many zeros? 4 zeros. 1, 2, 3, 4. So my final answer should be somewhere around 280,000, or at least have 6 digits in it. So let's start it out. 662. Actually, I'm going to put it a little further to the right because remember your products are going to be pushing over to the left. So 662 times 372. So put your work on the right-hand side of the box. 2 times 2, 4. 2 times 6, 12. Then 12 again plus 1 is 13. Next row down. First spot has a 0 because this is 10 times, or it's 70 times. We're in the tens place. 70 times 662. 7 times 2 here is 14, carry the 1. 7 times 6, 42 plus 1 is 43. 7 times 6, 42. 43, 44, 45, 46. That's your sevens. or your 7 tens. Now we're moving on to our 300s. So hold 2 zeros here because of 300. 3 times 2, 6. It's 300 times 2 for 600. Check that you're in the right place, then move on. 3 times 6, 18. Carry the 1. 3 times 6, 18 plus 1 is 19. Okay, then we're going to add those. 4 comes down. 4 plus 2, 6. 6, 7, 8, 9, or 6 and 6 is 12, however you want to add that. 8, 9, 10. Now 10 plus 6 is 16. 9 plus 1 is 10, and then we get 14, and then 2. I know I'm going fast. I apologize, but it's a long lesson. I want to make sure you guys get it. So 246,264, compare that with 280,000. We have 6 digits, 2 in the 100,000s place. We're good to go. Okay, next one. Again, they're going to be all over the place, so some people may round a little bit differently. If you look at the 73, that could round down to about 700, 442. Some people may want to put 450, and I wouldn't stop you, but you can't as easily do that in your head. So 44 would round to 400 for me, and then I would just do 7 times 4 is 28. And again, 1, 2, 3, 4. Count up the zeros, and you're looking for approximately 280,000. 739 times 442. Okay, let's start multiplying. 2 times 9, 18. 6 plus 1 is 7. 7 times 2 is 14. Next row. This is the tens place. So if you hold that ones place with the 0, you can use the 4 tens. 4 times 9, 36. 4 times 3 is 12. 13, 14, 15. 4 times 7, 28 plus 1 is 29. Next row. Now I'm multiplying with the hundreds. So get over to the hundreds place. 400. 4 times 9 is 36. Carry the 3. It's already there, so we'll use that one. 4 times 3 is 12. 13, 14, 15. Carry the 1. 4 times 7, 28 plus 1 is 29. 295600. There you go. Now let's add these. 8, 7, and 6 is 13. Carry that 1. 6 and 4 is 10. 15, 16. 9, 10, 15, 16. 9, 10, 12, and 3. 326,638. Compare that with what you started with. It has 6 digits, okay? And this is 20,000 away from 300,000. This is 20,000 over 300,000. So they're about 40,000 away from each other. Not ideal, but it's going to be okay for today's purposes because we're just trying to get close. Now, here is what I always say. Watch for the factor with a 0. If the factor with a 0 comes first, use the commutative property and just move it to the other side, because whenever you have the opportunity, you want to put the 0 on the bottom. It will save you from multiplying the tens. Okay, so just like lesson 7 on the previous video, watch how to control your zeros and to save yourself some work. 7 times 1 is 7. 7 times 9 is 63. Carry the 6. 7 times 4 is 28. Then 29, 30, and then plus the 4, 34. Now I have 3,437 for my first partial product. So I'm going to hold this 0 as if I'm done with the ones and I go to the tens. But now I have 0 for the tens. So I'm going to hold this spot, and if you're still wanting me to use the colors from previous videos, that would be like the first 0. This would be the row with 2 zeros. And now, again, I'm multiplying with 800 in the hundreds place. Put your answer in the hundreds place. 8 times 1, 8. 8 times 9, 72. Carry the 7. And then 8 times 4, 32 plus 7, 39. Now, it doesn't matter that it sticks way out here. Each number or digit has to be in its own place value position. So then let's go ahead and add. 7 comes down, 3 comes down, 8 and 4 is 12, 3 plus 3 is 6, the 9 comes down, the 3 comes down. Put your comma in, 396,237, and compare. Oh, and I forgot to do the, that's what I love about estimating. Okay, if I had 800 times 500, watch for our estimated total, because again, we're supposed to be comparing with our estimated product. 8 times 5 is 40. And then I have 2 zeros from the 800 and 2 zeros from the 500. And I should have an answer around 400,000. And I do. I have 396,000. Super close. Okay, now this one, if I have 3,502, I'm right smack dab in the middle of 3,000 and 4,000. So sometimes I'll look at the other factor and decide, do I want to go up or down with one? And you know, the opposite with the other. So let's say I take this and I round up, then I might round down here, okay? So 3 times 7 being 21, and then I have 3 zeros from the first factor and 2 from the second, and I would end up with something over 2 million. So let's give lots of room here. 3,502 times 656. Let's go. 6 times 2, 12. Carry the 1. Oops, but it falls down because 6 times 0 is 0, and then the 1 comes down. 6 times 5 is 30. 6 times 3, 18, 19, 20, 21. That's the 6. Done. Hold the spot. Get over to the tens place. 5 times 2 is 10. The 1 goes up. The 1 falls down. 5 times 5, 25. Carry the 2. 5 times 3, 15, 16, 17. This is row 3, or the hundreds place where I am multiplying. 6 times 2 is 12. The 1 goes up. The 1 comes down because 6 times 0 is 0 plus the 1. 6 times 5 is 30. Carry the 3 this time. 6 times 3 is 18, 19, 20, 21. Hopefully I didn't mess that up. 2, 1. 2 plus 1 is 3, 5, 6, 7. 7 plus 2 is 9. The 2 and the 2. Put your commas in. 2,297,312. And again, check with your estimated product. It's over 2 million. We're good to go. Let's move on. Oh, and I think this one, this is actually a misprint. You have not been given decimals yet, so that should be a comma. So I believe that's probably a misprint for the 2021 school year. So watch out. That's supposed to just be a comma. And at that, let's just approximately round to 4,000 times. Now that one went down. Well, this one we can just go down as well if you are so inclined. Then go ahead and multiply. 7 times 4 is 28. 3 zeros from here, 2 zeros from here, and then you should end up with almost 3 million. So let's see how close we get. 4,390 times 741. All right, zeros on the top are always fun. 1 times 0, 0. 1 times 9, 9. 1 times 3, 3. 1 times 4, 4. 4,390 times 1. No surprise. Next one, it's 410. So if you put the 0 here and multiply, starting with the 4. 4 times 0 is 0. 4 times 9, 36. Here's the 3. Here's the 6. 3 times 4 is 12. 13, 14, 15. Carry the 1. 4 times 4 is 16. Plus 1 is 17. Next row. I'm in my hundreds place. Get over there. Hundreds place. 7 times 0, 0. 7 times 9, 63. Carry the 6. And then 7 times 3 is 21. Plus 6 is 27. 7 times 4, 28, 29, 30. 0, 9, 9, 9, 10, 11, 12, 14, 15, 2, and 3. Put your commas in. 3,252,990. Check with your estimated product. Almost 3 million, a little over 3 million. We're pretty close. Okay, lots to do today. Roughly estimate 500 times 2,000. Going to be about, there's my 10. 2 zeros from the first and 1, 2, 3 zeros from the second. About 1 million. Let's lay it out. 2,075 times 530. I love the zeros on the bottom. It's going to help us out. 0 times everything is 0. Let's move to the tens place. Okay. 3 times 5 is 15. 3 times 7 is 21 plus 1 is 22. 3 times 0 is 0 plus the 2 is 2. 3 times 2 is 6. Next row. Done with the ones, okay? Done with the tens, because I already did the 3 times 5. So I'm over to the hundreds place, okay? So this is from the ones. This is helping us now. So this is usually what row 2 would look like, okay? And this is like what row 3 would look like. Okay, 5 times 5 is 25. 5 times 7 is 35, 36, 37, and then 0, and then 3, and then 10 out here on the end. Okay, add those up. 0, 5, 7, 9, 9, 0, 1. Commas, commas. And how close are we? About 1 million, about 1 million with the 99,000. We're close enough. Okay, bravo. Let's do another one. Approximately 4,000 times approximately 600. And 6 times 4 is 24. And 3 zeros and 2 zeros. Okay, so set it all up. Remember the real number, not the estimated numbers. Sometimes kids love estimating so much they'll just do all this with estimating, and I'm like, oh no, you have to go back and do the whole thing over again. Lots of zeros. This is so fun. 3 times 4 is 12. Why am I putting that? Because 3 times 0 is 0 plus the 1 here. Then 3 times 0, 0. 3 times 4, 12 again. That's a fun one. Okay, now we're done with this, so we go to the tens place. But this has a 0, so everything times 0 is 0. Now get over to the hundreds place. 6 times 4, 24. 6 times 0 is 0 plus the 2, because that just falls down. 6 times 0 is 0. 6 times 4 is 24. And now you've got this fun-looking number that we're going to add. And if my bell goes off, just ignore it. And then we add 2, and then 1, and 4, and 2 plus 2 is 4, 1, 4, and 2. And put your commas in and see how far away we are. Very close. The lights. Oh, and I forgot to turn the light on. Hey, we can fix all those problems in one fell swoop. Okay. Notice how close this is. 98 is close to 100, so that's 1,000. 987 is close to 1,000. This is close to 3,000. 1 times 3 is 3. 3 zeros from the first and 3 zeros from the second. Our total should be around 3 million. 3, 1, 0, 5 times 987. And because we have 987 on the bottom, it's a lot of high facts. So let's get going. 7 times 5 is 35. The 3 goes up and then it falls down. Here's the 7, and 7 times 3 is 21. Hold the spot for this. Get to the tens. 8 times 5 is 40. The 4 goes up and then it comes down. 8 times 1 is 8, and then 8 times 3 is 24. Last row, we're in the hundreds place. 9 times 5 is 45. The 4 goes up, the 4 falls down. 9 times 1 is 9, and 9 times 3 is 27. And then these all add up, 5 and 3, and there's the bell. It's time to go home, but not for me. This is 9, and 9 plus 7 is 16. 8, 9, 10, and then 4 is 14. And if anybody walks in, we'll ignore them. 9 plus 1 is 10, plus the 6 is 16. 7, 8, 9, 10. Add that last one over here. And double check and see how close you are to your estimated product. And you are still very close to 3 million. Now that is a lot of work, but we still have more. But they are in the form of word problems. So it shouldn't be too bad, because there are only a few left. Each container holds 1 liter and 275 milliliters. So this is, it's like saying it's over 1 liter of liquid. How much water is in 609 identical containers? And then find the difference between your estimated product and the precise product. So one thing we haven't really talked about in a while is how to look at whole numbers, which is the U from the King Henry died unexpectedly drinking chocolate milk column, the units, and the fractional units. So basically 1 liter, 275 milliliters, is equal to 1.275 because it goes tenths, hundredths, thousandths, and a milliliter is 1/1000th of a liter. So trust me on this. This is what you probably don't know, but just put this. That's what this is right there. And so if they want to know how much water is in 609 identical containers, then we have to multiply by the 609. Now, they also are asking us to estimate. So I would use an estimate like this, okay, to show my work. Now, remember, if this is 1 whole, then essentially what we're saying is it's 600 times 1, okay, which would give us 600. Now, I can have the extra zeros here if you'd like, but it's essentially 600 times 1. Now, let's multiply and see what we actually get. So 9 times 5 is 45. 9 times 7 is 63, 64, 65, 66, 67. Then we have 18, 19, 20, up to 24. 9 times 1 is 9, 10, 11. Okay, don't pay any attention to the decimal just yet. Done with the ones, okay? Done with the tens. That's going to be 0. Go to the hundreds place, start here. 6 times 5 is 30. 6 times 7 is 42, 43, 44, 45, carry the 4, 12 plus 4 is 16. 6 times 1 is 6 plus 1 is 7. So now we add, these come down, 6, 7, 7. Now, previously we had talked briefly about what to do when you do multiply. If you don't get it or can't remember, no worries, I'm just going to tell you again. However many places there are in the factor is how many places there will be in the product. So you're going to go ahead and say 1, 2, 3, and then put 1, 2, 3, put the decimal right here. Trust me, it works. It's because if you look at the unit form, this is going to be thousandths times ones, and you will get thousandths and in your answer. Okay, so let's just put that in parentheses because if you put the decimal, you don't need unit form label. Now, take the exact 776.475 minus the 600, and if you want to put the 3 zeros, you're welcome to do that. So find the difference means actually do the subtraction. Look at all these zeros. It's going to make it so easy. 5 minus 0, 7 minus 0, 4 minus 0, decimal down. 6 minus 0, 7 minus 0, and 7 minus 6. And so the actual difference is 176 and 475 thousandths. Okay? So, yay. That is the end of that one. Now, how about number 3? A club had some money to purchase new chairs after buying 355 chairs at $199 each. There was $1,068 remaining. How much money did the club have at first? Okay, so we have some money. Okay, then they bought 355 chairs at $199 each. Now, we're not rounding here other than to just say, what if it was approximately 400 times 200? I should get around 80,000. Okay, so let's do the actual multiplication here so we can figure out how much they spent, okay, and then we'll see what is left. So 9 times 5, 45, and then 45 again plus 4, 49. 9 times 3 is 27, 28, 29, 30, 31. Next row, hold the ones, go to the tens. 9 times 5, 45 again, carry the 4. 9 times 5, 45 again, plus the 4, 49, carry the 4, 27, 28, 29, 30, 31. See a common theme? Look, you just did that. And then the next row, you have to get over to the hundreds place, so put your 100 there. 1 times 5, 5. 1 times 5, 5. 1 times 3, 3. 1 times 355 is 355. We already did this. Let's add. So bring it down. 9 and 5 is 14. 9, 10, 15, 16. 5, 6, 7, 8, 9, 10. And carry the 1 and 6, 7. That's all whole numbers. So we're around $70,645. So yep, that's pretty close. Now, that's what they spent. Now, if I had my first number, which the sum money is, and we spent $70,645, and then we had $1,068 left, then how much money did they have at first? And I could ask you, how do you get back there? How do you solve that? Just kidding, let's do it. You have to add this to this in order to see what they had at first. So 70,645 plus 1,068. If we add it, we can get back there. Okay? 8, 9, 10 plus 3 is 13. Then 10 and 11 and 7 and 1 and 7. And so the very beginning number should have been $71,713 at first. I hope these videos are helpful for you. Click subscribe and come back again. At first. There you go. Yes, even when we're not learning at home and we're just doing learning in class, I hope they're helpful. Okay, if you're a new teacher, I hope they're helpful. I have had teachers say, thank you so much. These are saving my life. Okay, let's read the last one because it has 3 parts, kind of a big guy. So far, Carmela has collected 14 boxes of baseball cards. There are 315 cards in each box. Nice. Carmela estimates that she has about 3,000 cards, so she buys 6 albums that hold 500 cards each. Will the albums have enough space for all her cards? Why or why not? Well, all right, if she buys 6 albums that hold 500 cards, then that's a definite amount. So we have 500 cards times 6 albums, and this is what the albums will hold. 6 times 0, 6 times 0, 6 times 5. Okay, so albums will hold 3,000 cards. Now let's take a look at what she has so far. She has 14 boxes and 315 in each box. So 315 times 14. So if you're looking at like an estimate, let's solve this. 5 times 4. Well, we should estimate first. If we have 14 times 315, if I have approximately 10 times about 300, then I'm looking for about 3,000. Okay, it's going to be pretty close. So when you look at your estimate, okay, from 14 I went down to 10, and from 315 I went down to 300. Will the albums have enough space for all the cards? Like, now is the time. Why? What do you think? You think yes or you think no? 3,000 is exactly how many cards can be held in the boxes, the albums that she bought. But she actually has 315. She actually has 14. So will the albums have enough space for all her cards? You could say no. She will not have enough space. Okay, and then why? And I'll show you. Okay, because when we rounded down, we're taking off 4 times 315. And so if you do the actual multiplication, you can see just how many we're off, or she's going to be off. 4 times 5 is 20. 4 times 1 is 4 plus 2 is 6. 4 times 3 is 12. And then hold that spot because we're in the tens now. 1 times 5 is 5. 1 times 1, 1 times 3 should be 315. 0, 11, 2, 3, 4, 3, 4. So compare 4,410, which is how many she actually has, the actual total, and look at the difference. So see, when you round down from 10 to 14. I should put this underneath it. Round down from 10 to 14 and round down to 300. What you're doing is you're losing 15 cards every time you repeat that number. So that's why, no, she will not have enough space. All right, so we did a little work ahead. How many cards does Carmela have? She has 315 times 14, and we should probably put that one there, but I'm not going to rewrite it because we're almost done. Okay, so you can have that one here. How many cards does she have? She actually has 4,410. And then how many albums will she need for all of her baseball cards? So if you look at the total that she has, 4,410 cards, okay, that she has, and then you can take away what she purchased, then you would see, do the subtraction, and you get 1,410 cards left out. And so now, if you look at how she's purchasing them, it's 500 cards in each box. Okay, so what we need is we need to figure out how to get the 1410 into these boxes of 500, or to divide that. Now, you guys haven't done a lot of higher number division, but I can help you through this. 500 cannot fit into 141, so you would put your first answer in your quotient over here. How many 500s can you get into 1,000? 2, and that's going to be 1,000. And then you would have 410 left, which is less than that. And that's going to be the cards left over. And you don't want to have any cards left over. So if you have 2 more full albums and you have 410 cards left over, that's almost another one. So you're going to take your 2 and then you're going to add 1 more album for a total of, she needs, you have to use your remainder, 3 more albums. And so how many albums will she need for all of her baseball cards? She will need 9 total. Okay? Crazy problems on this difficult lesson, but you guys got this. And come back again. We'll see you on the next video. Bye for now.